Hi folks, welcome back to Math with Captain Rod. Purpose of this video is to just kind of outline how to integrate powers of sines and cosines. So what we're going to be looking at are things like the integral of sine x to the nth power dx, or integral cosine to the nth power x dx. So examples, integral of sine to the fifth x dx, or maybe integral sine to the fourth power x dx. So the methodology behind integrating powers of sines and cosines are all dependent on these powers. The first thing we do is we look at the powers and we determine if they're odd or even. If the power is odd, then the idea is to take our function. I'm going to go ahead and use a numerical example, like integral sine to the fifth x dx. Take our function and divide it up into an even group, sine to the fourth power x, and a single, sine x dx. And now a u substitution of let u equal sine x. Oops, I'm sorry, I got to back up. The even power here can be written in terms of cosines by using Pythagorean theorem, because sine squared x plus cosine squared x is equal to 1. Therefore, sine squared x is equal to 1 minus cosine squared x. So that sine to the fourth, which we can think of as sine squared times sine squared, can be written 1 minus cosine squared x times another 1 minus cosine squared x, and then times our sine x dx. And now a substitution of let u equal cosine x will reduce this down to an algebraic problem, because if u is cosine x, then du is minus sine x dx. We look at our integral and we say, well, this is going to be 1 minus u squared. That's no problem. 1 minus another u squared. Sine x dx is almost identically du, but not quite. It's missing a minus sign. It's an easy fix. I'll just put a minus sign here and out front. This is now identically equal to du. So our new integral becomes minus integral 1 minus u squared times another 1 minus u squared times du. And I think what I'll do is go ahead and multiply this out. So this is going to be 1 minus 2u squared plus u to the fourth du. So now the integral of 1 times du is u. There's a minus sign in front of it. So the first term is integrating to minus u. The next term, this is going to be plus 2u to the third over 3, since the antiderivative of u squared is u to the third over 3. And then minus u to the fifth over 5, plus a constant I'll call c1 for a moment. The only thing left to do now is go back and rewrite our integral back in terms of x. So I'm going to go ahead and do this right here. So OI, original integral, is equal to, all right, minus u, but u is cosine x. So we're going to have minus cosine x plus 2 cosine cubed x over 3. I just got to come down here to continue this line. Minus cosine to the fifth x over 5. Plus, now when I go from this integral over u to this integral over x, this is some other constant. I'm going to call that c2, and that's done. So the general idea behind integrating powers of sine or cosine, if the power is odd, you separate one out. I call this herd separation. Whatever's left is guaranteed to be even now. Right? So for example, had this been ninth power, we'd have a single sine here, and then this would be sine to the eighth. Since this is an even power, you could think of it as a group of sine squareds. And each sine squared can be rewritten in terms of cosine using Pythagorean theorem. So this general form will work for any odd power of sine or cosine functions. Separate one out, take the even part and rewrite it using Pythagorean theorem here, and it'll reduce down to a algebraic type of integral, and then substitute back. So that's how odd powers of sines and cosines are integrated. Let me talk a little bit about even powers. Get rid of the stuff I don't need. All right, so even powers of sines and cosines. So for example, we're going to start with an easy one, integral of cosine squared x dx. So even powers are reduced by using the following trigonometric theorems. Cosine squared theta is equal to 1 plus cosine of 2 theta over 2. Sine squared theta is equal to 1 minus cosine of 2 theta over 2. So for an even power of cosine, what we do is we reduce the powers using these formulas. So this integral we can rewrite integral 1 plus cosine of 2x over 2 dx. And now, I'm going to go ahead and write this out. Now we're going to have 1/2 the integral of dx for the first product plus 1/2 the integral cosine of 2x dx for the second product. Now, 1/2 integral dx is x over 2. And then the antiderivative of cosine 2x is sine of 2x over 2 plus a constant. And that integral is done. I could rewrite it. Of course, these will simplify to 1/4. I think I'm going to just end this video here and save the tougher examples for another one, because the purpose of this video was to just kind of overview how to integrate powers of sines and cosines. And again, let me boil it down like this. Let me write one more theorem here and separate it. If you are integrating an odd power, like the integral of cosine cubed, cosine to the 5th, sine to the 9th, you separate one off and use this form of Pythagorean theorem here to set it up so that a use substitution will work very well. So I'll just say this. If the power is odd, you separate one off, and then you rewrite what's left using this form of Pythagorean theorem. At that point, a use sub should reduce it down to an algebraic integral. If the power is even, like cosine squared, cosine to the 4th, sine to the 6th, you use these formulas to reduce the problem down to until you get it to something that you can integrate. And I'll go ahead and save the examples for the next video. Right? Have a great day.